All right, the last theorem for 10.3 is a congruent chords theorem. It says two chords are congruent if and only if they are equidistant from the center. Well, if you break down the word equidistant, it kind of sounds like equal distance. So, FG is congruent to HJ if and only if, and I'm going to use this little symbol here, means we can go both directions. So these two chords are congruent if they are the same distance from the center. So this segment LX and LY are the same. Okay? Or, so if we know that these distances are the same, the chords are congruent. We can also flip it around and say, hey, if we know the chords are congruent, we know that they are equidistant from the center. Okay? So these examples here, this distance here from T to H is the same as the distance from U to H. Okay, so since these are equidistant, we now know that these two chords are congruent. And so PQ is 3x minus 4. RS is 14. We can set those two equal to each other. And say, well, hey, x then is 6. Okay? So if we know they're equidistant, then we know the chords are congruent. Here, though, we know that WX is the same as XY, which is 22 units. Okay? And we are asked to find the length of AB. So here, we know that the chords are congruent, which means that these two distances are the same. They are equidistant from the center of the circle. Okay, so I'll set 5x equal to 3x plus 4. Gets me an x value of 2. But I didn't want an x value. I want the length of AB. And so AB was 5x. AB then is 10.